All right, hello once again. This is Jeff Scott of Rankin Technical College, and we've been talking databases. In particular, we've been going over the third edition of SQL, A Beginner's Guide by Andy Oppel and Robert Sheldon. And I've gone through the first first five chapters. We had an introduction to relational databases in SQL, working with the SQL environment, creating and altering tables where we went over the basic data definition language or schema type uh, of commands, those being in particular create, alter, and drop. We talked about enforcing data integrity, and we just finished a very short chapter on creating SQL views. Now I'm going to go through one more chapter here today, and that chapter is on managing database security. As you can see, this is what the chapter encompasses. Again, it's another fairly short chapter. I want to concentrate on the first thing that's in there, and that is understanding the SQL security model. After that, they talk about roles and privileges. Now, when you set up accounts for SQL users, you can make those, you can give set up accounts for individual users, or you can make roles. All right, and what a role is basically you can assign a bunch of privileges, a bunch of rights for people, and rather than having to say, I want this user to give them that role, this user give them the same, this one the same thing. So if you wanted to give an entire classroom, for example, every single type of permission there was under the sun, let's just say, you could create a role that was maybe called student, and you could apply those roles to individual users, and it would be faster than creating those users and then having to create um, the roles individually for each one. In some ways, at least, it's kind of like the idea of using more like a batch file or running something where you put it into a loop type of an idea. So we'll talk about that, but I'm not going to spend very much time on that. When we get into the next part of the book, Chapter 7, Querying SQL Data, Chapter 8, Modifying SQL Data, Chapter 9, Using Predicates, Chapter 10, Working with Functions and Value Expressions, Chapter 11, Accessing Multiple Tables, and Chapter 12, Using Subqueries. That's the crux of these lectures that I'm going to give, so that's what I'm going to spend the most time on. I'm not going to go over part 3 of the book because in the amount of time that we have to go over this material, there's just no way we could get there. So I'm not going to talk about creating SQL invoked routines, triggers, cursors, transactions, accessing data from the host program, working with XML. So I'm not going to go over those. If we have time, we might go over some of the stuff in the appendices. We'll see as we get going. So as mentioned, I want to talk Chapter 6, Managing Database Security. And in particular on those 4 bullets that are right there. Understand the SQL security model, create and delete roles, create and delete privileges, and grant and revoke roles. I'll spend almost 100% of the rest of this lecture on the first bullet. Understand the SQL security model. And again, just by reading this chapter, by no means do I mean to say, oh yeah, you'd be an expert after you read this. All right? But it's a good start. A critical component of any database is the ability to protect the data from unauthorized access and malicious attacks. One thing you have to realize that if you work at a firm that has a total online presence, and there are scores of them, there are millions of them around the world, where you may provide a product, you may have a website where people can order that product, but you don't have an actual brick and mortar store where people can physically walk in and get the product. All right. So the reason I'm telling you that is data is everything. If your data gets compromised, you could possibly even go out of business. All right. So as mentioned there, a database must ensure that no unauthorized users can view or change data that they should not be viewing or being allowed to change. At the same time, authorized users should be prevented from accessing any information that should should not be prevented rather from accessing any information that's available to them. The ideal balance is to give every database user exactly the privileges they need to do their job, and that's it. Sometimes in programmese, this is referred to as the principle of least privilege. You allow something to do what it's supposed to do and no more. In order to support these capabilities, SQL defines a security model that allows you to determine which users can access specific data and what they can do with the data. At the core of this model is what's known as the authorization identifier. Now, this shouldn't be anything new to you, and I may have even given the quick little analogy that I'm going to give to you right now. I may have given it to you in an earlier lecture. I don't remember. But I remember years ago going into the bank where I did the majority of my banking because I wanted to get out, I wanted to take out a loan. And I was going to get a car, and I wanted to see how this bank could compare against getting the loan from the car company, etc. So I went in and talked to the teller a little bit. Whoops, sorry. I went in and talked to the teller a little bit and told the teller of my situation, what I was looking for, what I was looking to try to do, etc. And he came back to me and said, basically I'm a teller and I don't have the ability to answer questions like that or to check that kind of information on your account or accounts, etc. But if you go over there, you could talk to the personal banker. All right, so I walked over, waited for a while because she was busy with someone. But then I asked, if she had a couple minutes. She said, sure. And she said, I want to let you know, though, I'm waiting for a call, and it's of a personal nature. Fine. So we started talking. She said, well, what are you looking to do? I said, I'm looking to purchase a vehicle. How much are you looking to spend? I said, about $25,000. And how much are you going to put down? And I said, probably around 20%. So I was going to authorize her borrowing the other $20,000. So we just started talking. Her phone rang. She said, this is the call I was waiting for. So she stepped aside. Now, what I did next, is it exactly ethical? Well, it was my information. Her screen was turned a little bit toward me, but not very much. So I got up and literally walked into didn't sit down in her chair, but walked over to where she was. And I noticed that there was a boatload of personal information about me on her screen. Why am I telling you this? Well, you noticed that the bank teller, basically his or her job was to say, here are your deposits. Here you can do a deposit, you can do a withdrawal. I can maybe even give you a list of deposits and withdrawals from the last month or so. I can tell you your balance. All right, they may even I don't know, may even be able to handle a change of address or something like that for you. But if you want to do anything over and above that, you're going to need a personal banker. So the reason I'm telling you that is there's two different roles there. There's the role of a personal banker, which is limited, and there's the role of a teller that is limited, and the role of a personal banker that probably is about as close to unlimited as you can get. So the author mentions here at the core of this model is the authorization identifier, which, as we learn in Chapter 2, is an object in the SQL environment that represents a user or a group of users granted specific access privileges to objects and data within the SQL environment. Privileges on schema objects are granted to authorization identifiers. All right, so the ability to create things, the ability to update things, the ability to delete things. And that's more than anything else, that's what they're talking about in here. So, authorization identifiers provide the foundations for the database's security. Access to any and all database objects is permitted through these identifiers. If the identifier doesn't have the appropriate privileges to access a specific object, such as a table, then that table data is not available to the user. All right? And if I have confused you in my examples, then let's just look at a different one and make it real simple. Let's say that you work for a company, okay? The old Acme widget company. And you work here on the shop floor. So what do they have at the company? Well, they've got a lot of departments. They've got accounting, shipping, receiving, personnel, payroll, and let's just say workers. And I'm a worker. All right. If I need to find out, maybe I was not sent my W-2s and I should have been already because it's after February, the end of February or the end of January rather, when they're supposed to send them out. So who am I going to go to do that? Chances are I'm going to go to payroll. I'm not going to be able to go to a shipping and talk to a shipping clerk and find out payroll information on me. I'll have to go to the payroll department. Just as if I wanted shipping information, I would go to shipping. I wouldn't go to payroll. All right? Again, a place for everything, everything in its place. So the idea is that payroll is the one that does the job of working with anything payroll related and nothing else. So it says there in the bottom paragraph on the page, SQL supports two types of authorization identifiers. User identifiers, all right, which represents an individual or an application or a service, and roles, all right? And as mentioned there, a role name is a defined set of privileges that can be assigned rather to either a user or a different role. If a role name is granted access to a schema object, then all user identifiers and role names that have been associated with that can access the particular object. Role names, as mentioned here, are commonly used as a mechanism for granting a uniform set of privileges to authorization identifiers that should have the same privilege, such as people who work in the same department. All right. They can be created prior to the user identifiers. They can persist after the user identifiers referencing them are deleted. As mentioned, this is helpful when doing administration. In addition, SQL supports a built-in authorization identifier named public. Public includes everyone who might use the database. So if you wanted to take something and make it available literally to each and everyone, you could make it public. That said, public should be used with great care because it can open the door for people with ill intentions. In fact, many organizations ban its use completely. It's much like if you've ever done any work in programming, why you don't make your variables public. All right? You make your variables private if you use access specifiers like that. You almost 100% of the time will make your variables private and you'll make your methods public. That way, the only way to access your private data is via your public methods. All right? Okay. SQL sessions. Each SQL session is associated with a user identifier and a role name. The session is the connection between some sort of client application and the database. It's a linkage, so to speak. And if you're not sure what a session is, look at it this way. If you go into Amazon and you put a couple things in your shopping cart, whether you buy them at that time or not, Amazon starts to create what's called a session for you. It's a unit of work. It's something you're doing. That session will have an identifier with it. All right, that way if you leave something in your if you put something in your cart and you leave Amazon and come back later, it'll remember that. All right. So they go through an example on the page here where they say this shows a user identifier / role name pair associated with a session. When the session is first established, the user identifier is always the SQL session user identifier. So in other words, it's one that's created for you by the system. It's up to the SQL implementation to determine how a specific account becomes the SQL session user identifier, although it can be an operating system user account or an account specific to the relational database management system. So when you start out, it very well could be null. There's nothing associated with it yet. At any instance during a connection, the session is associated with the user identifier's role name pair. In other words, you're identifying the session with someone who actually exists. Now it says, let's take a look at what you can do with these identifiers. Access to a database is based on being able to access the database objects. For example, you might grant some users access to a specific set of tables, while other users have only access to specific columns within a table. SQL allows you to define access privileges on the following schema objects: base tables, views, columns, domains, character sets, collations, translations, user-defined types, sequences, triggers, and SQL invoked routines. Some of these we've discussed, probably more in a general nature. Some of these that are in this bullet list we will discuss in more depth and breadth of coverage later. Some of them, especially the ones near the bottom, we won't discuss at all. All right, for each type of object, you can assign specific types of privileges that vary by object type, such as, all right, these are your data manipulation language, or DML commands. Select allows specified authorization identifiers to query the data in an object. With the select, you can query the data or look at it in any order you want to look at it by, and you can filter it any way you want using a where statement. But with a select, you cannot change the data. With the other three, insert, you're adding new data, typically a new record. Update, you are updating or changing existing data. And delete, which allows you to delete certain types of data. And you notice you can do select on tables, views, columns, etc. Insert on tables, view, columns, update on table, view, columns, delete on table, view. Couple more on page 130. References, as it says, it allows specified authorization identifiers to define objects that reference the table. Triggers, we're not going to talk about triggers, but triggers are basically something that happens based on a condition or based on time. All right? I'd like to tell a story how very many years ago I was at a McDonald's, and it was kind of dead in there, and I started talking to the guy. I noticed that he had the manager tag on, the person who was waiting on me. And I said, somebody came in I could hear him at the next station, and they ordered a Big Mac. And we started talking, and I said, what exactly happens when they do that Big Mac? And he said, well, you know that there's two hamburgers on there. So what has to happen is that has to trigger something in our local database of the stuff we have in our freezer, and it has to decrement the number of all beef patties we have by 2. All right? So when you trigger something, again, you might work at a Ace Hardware, where if you got a certain type of screw, and when the inventory gets to be less than 100, it automatically kicks in an order for 500 more. Those are triggers. All right. Usage allows specific authorization identifiers to use the object in a column definition. Execute, that's more programmatic in nature. And under, which allows specified authorization identifiers to define a direct subtype on a structured type. Notice here, privileges are granted on database objects by using the grant statement. You can remove privileges by using the revoke statement. So, jumping into roles, and again, I'm not going to spend much time on this. For the most part, creating a role is a straightforward process. There's an example of it. The only required part is to create role. Okay, so I could say here, create role customers. Once I do that and create the role, we can grant the role to user identifiers or other names, but you have to set up something with it. When you grant privileges on an object, as you see on the bottom of page 131, you are associating one or more privileges with one or more authorization identifiers. All right, this set of privileges and authorization identifiers is assigned to the object, which allows the authorization identifiers to have access to the object according to the type of privileges defined. You must have the necessary privileges yourself on an object to grant privileges on that object. So if I own a table literally I've created it, and it's under my name, so to speak, then I can grant options on that to other people. But if I just used the table and didn't create it, then typically it wouldn't be me who could grant privileges on the table. It would be some kind of a database administrator. So SQL supports the following values for the object type placeholder, and you can see them right here. There's an example. And it says here, this select privilege allows all database users to view the data in the available CDs view. However, because public has not been granted any other privileges, users can view the data, but they can't take any other action. In other words, they can run select statements, they can't run updates, inserts, or deletes. Here's another example. This time the author is granting update, select, update, and insert, okay, select, update, and insert to the sales role and the accounting role. Okay. So you're virtually unlimited as far as what you can do. So you can grant privileges, but if you decided you gave them too many privileges to somebody, or they were gone from the company or whatever, you can also revoke their privileges. In much the same way, you can also both grant and revoke roles. And again, it works pretty much the same way. So there is an exercise in here where you create two roles in the inventory database, grant privileges to the public authorization interface, and to one of the roles you created, grant one of the roles to the other role. So it gives you some practice playing with this stuff, so to speak. And that pretty much is it for Chapter 6. I'm going to come back soon with Part 2, Data Access and Modification, where we'll get into Chapter 7 talking about querying SQL data. I'm going to take a step back before I do this. I'm going to go back and create an entire database before your very eyes, so to speak. It'll be simple, but we'll create the database, then we'll put the data in there, and then we'll start to manipulate the data by running some queries. And I'll be back with that shortly.